Welcome to 6.3 notes, logarithms and logarithmic functions. So we're going to start off by just defining a few things. So logarithm of y with base b function. That looks like this. I've got my log, my base b of y. A couple things about this function is that y and b are positive real numbers. And we don't want b cannot be equal to 1. We'll also be discussing the common logarithm, which just looks like log x, and we don't have a little number for a base there. So the common log means that it is a log with the base 10. So if you don't see something there, we assume it's 10. Then we have the natural log, which is signified as an ln, and that is a log, but its base is the number e, like we talked about in the last video. So if you notice here that log base b of y equals x, if and only if b to the x power equals y. So that's the base, and the exponent equals the y over here on the right, and on the left it says the log base, and the y are on the other side. Well, it said the log base b of y, but what's important to note about this is that they are inverse functions. And you can see that on the parent graph. So what we're accustomed to is we have up to now seen our exponential. When it's exponential growth, it hugs the asymptote and moves up and away to the right. And here, this is our line of reflection. That is y equals x. And on the other side of it, you have the reflection, which is the logarithm or the inverse function. And if you notice, they have those corresponding points, like when we discussed last chapter where the x's turn to y's and the y's turn to the x's when it is an inverse function. And that's, you can see an example of that right here. Well, and this also works for exponential decay. It just looks a little bit funkier. You know, it's a little bit harder to see. So this is what we're used to for exponential decay. It starts away and then it comes home sharply toward the asymptote and it goes through 0.01. Well, if we reflect that curve over this line, y equals x, we're still getting the same thing that we would expect from an inverse function, but it comes along right here. So you can see that these points, they match up, they're inverses of each other. They've just been flipped. There you go. So something to note about this is that the y-axis is a vertical asymptote of this one right here. So this right here, it has a vertical asymptote, meaning that, you know how before we would draw the dashed line right across the x-axis because that's what it was? Well, for the log, it's going to go along with the y-axis. So it's going to go up and down. So that's where x equals 0 is where that starts. And having said that, that means that the domain is now just greater than 0. All right, had a bit of a technical glitch, so let's get caught up here. We have that domain is 0 to infinity, and that now our range is negative infinity to infinity. So that domain is never going to go past that asymptote that goes up and down right there in the middle. So my domain is 0 to infinity, and then my range. All right. Now we're going to go through these examples pretty quickly because I think that you'll get the hang of it. And we're going to look at these and say, all right, starting first, we know that our log base is 10. Oh, we should look at the directions first. Let's redo this. We're going to rewrite in exponential form. So I'm going to be thinking to myself that I can expect to write an exponent. That's what exponential means to me. Okay, so I've got my base, log base 10, And I know that what this log does is it gives me the exponent. So that's going to move over there. And this is going to move over here. So same thing. What is my base? And it tells me what my exponent is. It says that if I take 5 to the negative 2, it will result in 1 over 25. Again, my base is 10. My exponent is 0. Anything to the 0 power is 1. My base is 1/4. My exponent is negative 3. And if I take 1/4 to the negative 3 power, I will get 64. Okay, now this time I'm kind of working the other direction. I'm going to rewrite it again, but this time I'm going to use logarithm form. So I'm going to be thinking to myself, well, I'm going to have to probably use the word log. Okay, so let's look at it. I know that I'm going to start out with the word log. And when I say it, it's log base something. So what's my base? My log base 12. And I know that whatever I have here is that this is my exponent is what a log will give me. So this is going to move in there. So do you see how now we're switching where it goes? It's going back over there. So log base 12 of 144 equals 2. So that says that what exponent do I need to turn 12 into 144? I need 2. So let's do it again. We've got our log base 20 of 1 over 20. And it says, well, what exponent would that be? That would be negative 1. If I have log base 216 of 6, well, what exponent would I need for that? I would need a 1/3. If I have a base 4, of 1, well, my exponent would have to be 0 if I wanted to get a 1. So now to evaluate it, that means I just have to find out, I've got to find the exponent. What exponent would I need? Okay, so you could do this a couple ways. You could start like we were in the beginning. We could say, well, the base 4 raised to some power that I don't know yet equals 64, and then I can reason my way through it. 4 times 4 is 16 times 4 is 64. So that happened 3 times, so my exponent must be 3. Or I can just simply ask myself, if I have the base 1/8, what exponent do I need to give me 1? That one's, it's almost cheating. It's so simple because we know that anything to the 0 power will give us 1. So again, 2 to what power gives me 1 over 32? Well, I know that if I'm going to take my 2 that's in the numerator and send it down, then my exponent's going to have to be, negative. And now I can think of, well, how many times does 2 multiply by itself to get 32? And that is 5. Again, I've got my base is 1 over 25, and I want to know what exponent will turn that into 1/5. Well, I don't need a negative, because a negative would flip it, and the 25 would be on top, and that's not what I need. But what I do need is that it's not getting bigger, it's getting smaller. So I'm going to be looking for a fraction exponent, because that's going to give me my root. So if I look at it, how does 25 turn into 5? Well, you square root it. So that's the same as writing it as 1/2. For the sake of the video today, we are not going to be doing number 13 and 14, so you can skip over those. We're going to do some calculator work, though. These are going to go really fast. First, I just want you to notice that somewhere, like next to the 7 on your calculator, there's a button that says log. When you push it, it will open up a parenthesis, and then you type in the number you need, close that parenthesis up, and hit enter. That will give you a number, and I want you to really pay special attention to how you're rounding, because I've been seeing a lot of mistakes on that. So the nearest thousandth means 3 decimal places. So if I look at my calculator, that will give me 0.778. If you don't get that, pause the video, give yourself a few minutes working on your calculator skills. Again, I will hit log 1 divided by 5. I'll close my parentheses, hit enter. If you don't get this number, take a minute, familiarize yourself with your calculator. Now we're dealing with another button here. This is the LN button, or the natural log button. It's going to work the same way. It is right next to, or right underneath that log button. And you should, if used correctly, get that as a result. Now finally, we are going to solve for an exponent, and that means we're going to be thinking, well, what does solving really mean? Well, since middle school, we've learned that solving is really just isolating x on one side, right? So x is with this log right now. I can't do much about that, but I can get rid of this by using inverse operations. That turns into a 0, so I'm left with 90 equals 45 times log of x. Okay, well, I can get rid of my 45 there, because the inverse of that is to just divide. And now I'm left with something that kind of looks like those first 4 problems I did. And I remember from the notes that if there is not a little subscript number next to the log, that it's my common log, which is 10, and that what's on the other side of this equal over here is my exponent. And there we go. So we've got 10 squared equals x. That's something I know how to do. 10 times 10 is 100. We're going to repeat this process over here. Again, we're solving for x using those tools that we developed in middle school. And if you'll notice here that this gives us a fraction that does not come to a pretty number, a clean number, so we're just going to leave it like a fraction that's more exact. And that's okay, because right here we're at that same point where we see we've got a common log, so it's 10, and we've got an exponent. It's okay if an exponent is a fraction. Fractions are numbers too. And this one we don't have to do in our head. You can plug it in your calculator, and if you do, and you round it to that nearest 3 decimal places like our directions tell us, you will get 25.118. If you don't get that, again, stop, take a minute to practice with your calculator and see if there's anything else that is not quite making sense. Other than that, you are now ready to do your assignment.